Hello and welcome to the video on K-nearest neighbors. In this video, I'll give you the basic understanding of K-nearest neighbors algorithm in machine learning, and will also show the practical implementation in a Jupyter notebook. So let us start. K-nearest neighbors is one of the simplest machine learning algorithms, and it is based on supervised learning technique. Now, KNN algorithm assumes similarity between new test data case that we are going to evaluate based on the trained algorithm and available cases, and it will put the new case into the category that is most similar with the available cases. So KNN algorithm stores all the available data and classifies a new data point based on the similarity. This means when new data appears, then it can be easily classified into a well-suited category by using KNN algorithm. So KNN algorithm can be used for regression as well as classification, but mostly it is used in classification problems. So I'll also show you one classification example using KNN when we move to the practical section. So KNN is a non-parametric algorithm, which means it does not make any assumption on the underlying data. Like, you don't have to assume that the data is in the normal form or not. So you don't have to take any assumptions. That is the one important benefit of KNN. It is also called a lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the dataset, and at the time of classification, it performs an action on the dataset. KNN algorithm at a training phase just stores the dataset. When it gets new data, it classifies the data into different category. Now let's take one example. So suppose we have an image of a creature that looks similar to the cat and dog, but we want to know whether it's a cat or a dog. So for this identification, we can use the KNN algorithm, as it works on a similarity measure. Our KNN model will find the similar features on the new dataset to the cats and dogs. Based on the most similar features, it will put either cat or dog category. So again, this is a classification problem. We have to classify the new input value into either a cat or a dog. So this is our problem statement. Now suppose there are two categories, category A and category B. We have a new data point x1. So this data point which will lie in these categories. To solve this problem, we need a KNN algorithm. With the help of KNN, we can easily identify the class of the category of the dataset. So just look at this diagram. Here you have two different categories. So all the data points of type category A are marked in blue, and all the data points of category B are marked in orange. Now this is before KNN. So now you have a new data point in dark blue color, and you want to classify it into category A or category B. So once you apply KNN on this data set and on the new data point, so it will be marked as light blue color, and finally we can classify this new data point into category A. So again, we have solved this classification problem with the help of the KNN algorithm. So let us understand how does KNN actually work. So the KNN working can be explained on the base of the following algorithm. So these are some of the steps of the KNN algorithm. So first we have to select the number of neighbors. So we want to select the nearest number of neighbors that we're going to use for comparison, and then we'll calculate the Euclidean distance of the new data point from all the nearest neighbors that we have selected. Let's say we have assumed 5 nearest neighbors for comparison. Then we'll calculate the Euclidean distance from the new data point to the all 5 neighbors that we are taking into consideration. Now take k nearest neighbors as per calculated Euclidean distance. This we already discussed. Among these k neighbors, count the number of data points in each category. Assign a new data point to the category for which the number of neighbor is maximum, and our model is ready. So let us understand with the help of this image. Suppose we have a new data point and we need to put it in required category. So here category A is in light blue color and category B is in dark blue color, and we have a new data point in orange colored mark. Now we want to classify it into either category A or category B. So let us say we assume that we are going to take k is equals to 3, that the number of nearest neighbors of this data point, and we are going to consider 3 nearest neighbors for this data point. So 3 nearest neighbors will be these 3 ones, and based on the Euclidean distance that will calculate in the real problem. But here by just doing a common observation, we can classify these 3 will be the nearest neighbors for this new data point. Now from these 3 neighbors, 2 belong to the dark blue category and 1 belongs to the light blue category. So by using the majority vote, like the majority stands for dark blue category, so this new data point will be classified into a dark blue category. So this is how KNN works. So this is the mathematical visualization for the same. Firstly, we'll choose the number of neighbors, and here let's say we choose k is equal to 5. Next, we'll calculate the Euclidean distance between the data points. The Euclidean distance is the distance between 2 points, which we already studied in geometry. So Euclidean distance is basically under root of x2 minus x1 whole square plus under root of y2 minus y1 whole square, and you just have to take the root of the entire value. So let's say if I want to this is a standard coordinate xy plane, and these are 2 points on the xy plane. The coordinates of point A are x1 and y1, and the coordinates of point B are x2 and y2. And if I want to calculate the Euclidean distance between these 2 points, I'll simply do under root x2 minus x1, the value of x2, I'll subtract it from x1, and then I'll take the square of this value, and then y2 minus y1, I'll square the whole value. Now whatever value that I get as answer, I'll take the under root, and this entire thing will be known as the Euclidean distance. This is very simple high school coordinate geometry. I hope you are very clear with this concept. Now here category A, if you look at this image very carefully, category A has 3 nearest neighbors and category B has 2 nearest neighbors. So for this example, we are considering the value of k equals to 5. So we are going to take in account 5 nearest neighbors, and from the 5 nearest neighbors that we are using, 3 belong to category A and 2 belong to category B. So as category A has more number of nearest neighbors to the new data point, so this new data point will be classified into category A. This is simple logic of KNN. I hope you are clear with the mathematical understanding of KNN. Now let's move to the Jupyter notebook and implement the KNN algorithm practically. So let us start with the practical implementation of KNN. First of all, I have already done all the code in Jupyter notebook just to reduce the length of the video, and I'll explain everything very quickly to you, because most of the life cycle of the machine learning algorithm or the project remains the same. Only the algorithm, the implementation of algorithm in the SQL and that changes. So first of all, I'll import the required libraries. I have NumPy, Matplotlib and Pandas. Now this is a data set that I'm storing in a Pandas data frame, user data.csv, by using pd.readcsv. Now I'm extracting dependent and independent features. So on my, first of all, have a look on the data set. So we have gender, age, estimated salary, and the target that we are predicting is purchased. So we have 2 categories, purchased or not purchased. So if we have 0 in the section of purchased, then the customer has not purchased, and if we have 1, then he or she has purchased. Then we are separating the target and independent features. Now we are using sklearn.model selection train test split. I'm using 75% of data for training and the test size is 25%. XY, Xtrain, Xtest, Ytrain, Ytest. Now it is a good habit to perform scaling if you are working with algorithms like KNN and or a neural network. So just to improve the results, I'm using the standard scaler. So I'll make the instance of the scaler, and then Xtrain fit transform and Xtest only transform. So this is for scaling. Now we have the data scaled. Now okay, let me add one more cell and show you Xtrain how it looks after scaling. So now we have both the features perfectly scaled between -1 to 1. Now what we are doing, from sklearn.neighbors, I'll import the k nearest neighbors classifier. So this is the algorithm that we are going to use. So I'll import it, then I'll make the classifier instance, and I will choose nearest neighbors as 5. So I'll use the nearest 5 neighbors and calculate the Euclidean distance, and based on it I'll predict the value of the new data point. These are some of the hyperparameters that we are not going to discuss in detail. Now I'll use the fit method and I'll train the model on Xtrain and Ytrain. So classifier.fit Xtrain Ytrain. Now I have the instance of the model. Now let us make some predictions. So predicting the test result. So we have the predict method and we are going to predict the value of Xtest. So I'll pass Xtest and then I'll store the predictions into Ypred variable. Now let us analyze the results, what we have achieved. So as you can see from the confusion matrix, actually the algorithm is working quite good. So we if you see the diagonal elements, we are having a huge a large amount of values are present in the diagonal elements, true positive and true negative. So the accuracy is quite decent. Now these two cells are for visualization. So this is the visualization for the code is for visualization of the training set, and this is the visualization for the testing set. So here we have estimated salary and here I have age, and then I'm predicting based on these two features. This is for the test set and this is for the train set. So you can have a look at the visualization and try to understand the algorithm in a better manner. I hope you are clear with the working of KNN, and now let's move to the